Hello, welcome back to another video of Brain of a Penguin's YouTube channel. Today, I'm having a nice day. I hope you're having a nice day too. It does bring some joy to your day. If you're not having a nice day, I suggest having one. It does make your days more enjoyable. Well, anyway, let's get into the video. So, how do you divide fractions? Stick around to find out. At first glance, these expressions may seem complicated with no obvious place to start, but don't fret and turn that frown upside down. In my other videos, you hear me talk about explained and not explained topics. An explained topic is a topic that must be explained to you first, the building blocks, per se, of math concepts. Not explained topics are math topics that you could learn from a teacher, but you can also learn from intuitively discovering patterns from your explained topics. Dividing fractions, you may notice, is an explained topic. From finding patterns with math concepts we have learned in the past and a basic idea of fractions, we can figure out how to divide fractions without searching how to do it. Here, I have an example of what a not explained topic may look like. We may learn how to add, in this case, two terms, but we want to learn how to add a third term. Instead of searching up how to do this, we can figure out that adding three terms is not much different than adding two terms and intuitively figure out how to add that third term. Now you may be thinking, well, Mr. Minecraft Penguin, adding is easy and anyone can figure that out. My response to this is that, like riddles, math concepts may make more sense when you know the answer, but while you can answer 1,000 math problems, you can only learn how to do them with a fresh mind once. A riddle is ruined for you to solve on your own once you already know the answer, so why not make the travel worth the time? Anyways, moving on to the reason why you came to watch this video. When we have not explained concepts to learn, we start with the givens, or the math concepts we have learned before. Here, I am stating that 2 is equal to 2 upon 1. I know this to be true because any number over 1 is itself. Another given I have is a true division equation with a fraction, stating that 1 upon 2 divided by 2 is a fourth. This is also the same as saying 1 upon 2 over 2 is a quarter, or more simply, half of a half is a quarter. Now I have combined both of my givens to make a new equation, which I know is true because the two above givens are also true. Okay, I understand what you told me, but why must I know these givens? Well, the reason we look at givens so much in math is to find patterns in math, using the original givens to discover and prove new concepts, what my channel is all about. This can be similar to how even if a hypothesis in science is obvious, without enough evidence and reasoning to back the hypothesis up, there is no reason to claim it. Moving on, the big picture of why I am talking about givens and finding patterns is because we will find patterns with true division and fraction equations to develop a method in which we can successfully divide fractions, but without me telling you the answer right away. At this point, I am sure you know about these explained math concepts, and we will put your skills to the test to try and find patterns with dividing fractions. Now, our job is to creatively find patterns with this true division statement from our givens at the beginning of the video. Let me try to find one. How about this one? Here, I can see that 2 plus 2 is 4, so could a pattern be to add the diagonal, like so? Well, that can't be true because I see here the other diagonals to be 1, 1, and 1. I know that 1 added to 1 definitely does not equal 1, so my theory cannot be correct. One quick reminder, I may be trying to find the pattern, but if you can find it yourself or at least try to find the pattern without mindlessly listening to me, that would be ideal. Back to work. Back at the same equation again, if you would like to try and find the pattern now without it being revealed to you later, you may now pause the video. Now back to finding the patterns, I am looking again at the Let's call them the diagonals of the equation, and I can see 2 multiplied by 2 is equal to 4. Let us check this validity with the second theory with the second set of my so-called diagonals. Yep, I can see here that 1 multiplied by 1 is equal to 1. So now we have a so-called method that we can use. Let us see if this really works, if it works on the equation. Behind this gray bubble, I have the true answer to this. Using our developed method from before, we would just multiply 1 by 5 to get 5 as the numerator and 3 by 3 to get 9 as the denominator, getting our answer to be 5 over 9. Let us check if this is true. Here, I see that the answer is true, meaning the method that we have works, and it is easier to state that this will be our equation, with A over B divided by C over D is A over B multiplied by D over C. Here we can notice that the change is by swapping the numerator and the denominator of the second term and changing what we're doing from division to multiplication. You may notice, if you've seen my other videos, that the C over D to D over C is also known as a reciprocal, which you can see a video by clicking right here. Also, once we know how to convert the division into multiplication, we can then refer to this multiplying fractions video. For now, I will continue with one last example as if you've watched this video and know how to multiply fractions. This will be our last example of the day before I go into a summary slide. Here I can see we are trying to find 1 and 3 over 4 divided by 5 over 2. Well, using the method we have from before, I can say that 1 and 3 over 4 divided by 5 over 2 is the same as multiplying by 2 over 5. If you have watched my multiplying fractions video, you know that I would like to convert this mixed number, the 1 and 3 over 4, which is a number plus a fraction, into an improper fraction. So I can now have 7 over 4 multiplied by 2 over 5. Again, I also have stated in my video that this 2 and 4 can be simplified, so we have this expression, getting ourselves this answer. If you are confused on how I could have gotten this answer, make sure to watch the multiplying fractions video. The dividing fractions video here is mainly just a setup to how we can convert the division statement into a multiplication statement. Here we can see that dividing fractions is a not explained concept, or that we can find a pattern without me directly saying how we can convert the division into the multiplication. We know that dividing fractions is the same as multiplying the reciprocal. Make sure to watch that video. Once we know how to convert, we can just refer to what we know about multiplying fractions instead of relearning it again. Do you have an idea for a future math video that you want gone over? If so, comment it below. Also, my email is thepenguinbrain@gmail.com. Thank you for watching and have a nice day. So, you know how I wanted you to have a nice day at the beginning of the video? Well, if you haven't been having a nice day, you can have one now, because who wouldn't love to watch this? No, the pigs are gonna fall. Boing, 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 boing.